Okay, guys. So data visualization, right? So what? I mean, most of you will be thinking, why do we need data visualization? Why are we even studying this part of the programming, these concepts? So data. Basically, first let me tell you what data visualization is. Data visualization is creating graphs, working with the graphs. If you have got a bunch of data, like lots of rows and columns of a data, and instead of reading all that data or just manually reading them, looking at everything, you can properly work with it. Even with the help of the pandas library, you can get a calculative idea of all that data. But when we use graphs, we get a very good and accurate, means we can visualize the data, like what's happening in the data, what data is trying to tell us. That's why data visualization is a very important, I would say, a most important part of the machine learning or deep learning, even the data analytics field, where you are trying to work with the data, where we are trying to understand what data is trying to say to you. For those purposes, data visualization plays a very important role. But most of the people, they are making machine learning models, they are working with the machine learning models, but they are not working with the graphs. They are getting some kind of an organized data, and they are just putting their data into they are cleaning the data and they're putting the data into the machine learning and the models, creating the models out of it. But they are not thinking like which columns are important, how one column is giving an impact on the other column. That is what we visualize, we see with the help of creating graphs, by visualizing them, what is more important and what is less important, which column should be given priority, which not. Yes, we can do all of these things by putting out by taking out p values and all, but these concepts, I mean, those are, yeah, they can be done with that way. But these concepts of data visualization, you will see when I will be visualizing the data sets. I will be at the first, I will be explaining you what is this library and what are the basic concepts of the library. And then at the end of the this tutorial, this workshop, I will be explaining you using a real one data set, and I will be showing you how we will see what columns are impacting on the others, how they are giving an impact, how much impact, and just by using one line or two lines of code and creating out graphs of it. Okay, so let's start. We are talking about data visualization using matplotlib. So obviously we will need a matplotlib library over here. And if you have downloaded Python through Anaconda Navigator or Anaconda distribution, then this matplot library will be inbuilt into your machine. And if you are on a Colab, like right now I'm on a Colab, Google Colab right now, and I would also suggest you to be on Colab right now, because there are some things that are very much complicated while running on inside of the machine, because there are some difficulties, or some task needs to be done, like there are some files you need to download and set up as a environment variable, and that I'm not discussing it today. So that's why I haven't chose Jupyter or the Spider notebook. I've used Colab today, because right now we are directly connected to the internet, and whatever we download it over here, it remains on Colab directly. So if you're on a Colab, then matplotlib library also, it's already installed in the Colab, so you can directly import this library using import matplotlib.pyplot as plt. Now this library is the most important library of Python to create graphs. Okay, so I'm just gonna run it and see if it is getting imported. Okay, you can see the file run and it's imported perfectly fine. We're not gonna bother this. You can learn this code, or you can write it somewhere. This is a code to import your Google Drive in the Colab. Like if you want to use some files inside of the Colab, so you can either upload it directly on the Colab, or you can save it in your drive and upload the whole drive over here. Mount the drive over here, sorry. So, but I'm not gonna mount it today, so I'm gonna just leave this code as it is. I don't need it. Now the graph section. Now you see here I've created two lists. One is X and the other is Y. And I have wrote a simple syntax, PLT. What is PLT? PLT was an alias for matplotlib.pyplot library module that we have imported. And I have used a simple method of it. It is plot. PLT.plot. Plot means we are plotting a graph. Okay. And I've given two coordinates, X, Y. And now if I run this line of a code, let's see what happens. Okay. I got a graph over here, and whose x-axis are what we have given in the here, x 1 2 3 4 5, and y is 2 4 6 8, 10. Now what happens is I won't explicitly declare the accesses. So what it's gonna do, it's gonna work within this range, and it's gonna create its own what do you say, grids over here, these points, access points over here, okay, between the range of 1 to 5 and 2 to 10 over here. And it's gonna plot the x comma y graph between them, like 1 comma 2, 2 comma 4, 3 comma 6, and creates a line over it. So this is the basic starting of how we create graphs. We need axes, and then we plot those axes using plot method, and many other methods are there according to our requirement that we will study further in this workshop. So now this was the basic concept, and now if we move forward, then again what I did, I've created, there were two already, x and y. I've created one more list, x1 over here, which I've given 1, 3, 5, 7, 9 the odd numbers. And now what I did, I said plt.plot x comma y, as we have talked earlier, plt.plot x comma y, and then I said label is equals to first line. Okay, forget about this label part for right now. Okay, we will discuss it later. Let me remove it just. Okay, let's start a simple link. Yeah. So what's happening over here is, let's move this part also. So what I'm doing is I'm creating two plots over here. One is of x comma y, another one is of x1 comma y. And then what I'm doing is I'm labeling these axes. Now to label these axes, now this is, you can see this is like an empty graph, not a proper graph. What a proper graph would be, there's a name for the y-axis, there's a name for the x-axis over here, there's a title for the graph, and that would all comprise it makes it looks like a proper graph. So that's what we are doing. We are giving it an x label. So the simple method is plt.x label, and what it does, it gives an x-axis. Okay, and we name, just put a string over here, x-axis. Now it will rename that axis as x-axis, and same thing is the plt.y label, and it will create it as a y-axis. So here it will write y-axis, here it will write x-axis. You can write whatever you want over here in these places. It's your choice. Whatever x-axis is defining, you can write it over there. And then plt.title I gave hello graph, and this hello graph is the like the main heading or main title, and the first graph is like the subtitle of that graph. So now if I run it, let's see. Now you see I plotted two lines over here. One is x comma y, and the one is x1 comma y. And you see this, there are two lines over here. And earlier you see there was one line and it has took a blue color. Now we are using two lines, so it Matplotlib has a specialty. It auto adjusts the colors, like it does not convert both the lines as a blue. If there are two plottings inside of one graph, then it will change the colors of the line. That's a good thing in the Matplotlib. And you see here, it named the x-axis as x-axis and y as y-axis, as we told it to do. And here in the title section, it gives hello graph and the first graph. Okay. So now we were talking about labels. Now, before coming to the label part, now you're saying here, I've given it x label, x-axis, y-axis. You can also change the font size. If you give it here size equals to like, I say 30. Okay. And in this, I will show you something different. Here, I will say what we can do. Oh, there's nothing much. Okay. Now I can put a color over here, and I can say red. Okay. Now let's see. If I run this, now you see here the x-axis I have increased the size by 30. You see this x-axis become a size increase, and the y-axis I said color is equal to red, so its color became red over here. Now you can put both of the. I showed you both of the things using in another, so that I don't have to run it again and again. But now you can put a color over here also. You can say color is equals to, and you can give it green, and it will accept the green color, and it becomes x-axis becomes green over here. Now let's talk about the label that I said over here that time. Now if I say label is equals to, and I give it like a first line, and for this I give it a label. There are two lines I've run. Let's define them what they are. So I say second line, and they are strings because I'm writing it as a string over there. Okay. Now, and this legend. I will explain you what legend is. Let me run the code first. Okay, you see here, this block you see over here, this is called a legend. And what legend requires is like whatever you are drawing in the graph, just give it a name, give it a label over here. The legend will automatically check what labels are provided over here, and it will automatically helps you, it will create a block over here defining what is what. So you see, this was our first line, blue color, and it says the first line, orange was the second line, it defined its second line. Now this is the task of a legend. Now, you see, this is a lot, means, it is much difficult to read like this. You have to check it, you have to create, means you have to see what, like by using the mouse, which point is this. You can also put one more, there is a method in this, that is plt.grid method. And what it does is, it will create a grid lines over here so that you can easily read your whatever the data, whatever the graph is trying to say to you. Okay, there are lines, you can read it. This is 4,2 point, this is 5, 2.5 something. So that's how you can read the whole graph over here this way. Now there are some more methods in this. Let's explain you in this only concept. Now you can also put let's say plt dot you can, and this you can also give it a limit. You can explicitly provide it the limits, like from which point to which point you want your x-axis to go, from which point to which point you want your y-axis to go. So there are two methods called xlim and plt.ylim. Okay, so now what happens is they two parameters each. One is initial parameter, like if we're talking about x limits, then left, one is left side of the limit, and the other is the right side of the limit. If you're talking about y lim over here, then top limit and the bottom limit. So we can give it our two parameters, like let's say I want to give it 0 to x has to go to up to 10. Right now, if you remove, right now x is going up to 9. Okay, let's change it, let's make it a little bigger. X has to go to up to like 15, and y also has to go up to 50. And now if I run this code, now you see our graph is from 0, 0 to 15 over here, and that's a 15, 15 graph. And here these are our lines, this is our legend. So that's the task of the, even if you want to print the value of, like if you have a graph over here and you want to print the values of the limits of that graph, what are the x limits and the y limits? So you can simply say, as I told you, x limits contains two values. So you can say left comma right equals to plt.xlim, and here you can say top comma bottom is equals to plt.ylim. And if I run this code, okay, I have to print it also. And left, let's print only one thing, okay, to give you just the idea. And you see here it is printing with the left 0.6 right now. Okay, so what happens is it's starting from the 0.6. It's not starting from the 0. Okay, earlier you might be thinking that it was starting from 0, 0, but no, it is not starting from 0, 0. The x-axis is starting from 0.6. And if we talk about the y-axis, let's say okay, that's okay, I have given it opposite. It should be bottom comma top. If you run it, now y is starting from 1.6. okay, that's the bottom limit of the y. But when we let's remove it all. Now when we were giving the limits like 0, 14, okay, then what is it automatically checks that, okay, I'm giving it explicitly, I'm providing it to limits 0 and 14. So what happens is the graph automatically converts into those two limits, 0 to 14. Okay, that's why when we earlier we saw that our graph shifted to from 0, 0. And you see here, now our graph is explicitly starting from the 0, 0 and going up to the 14. As I said over here, it has to go up to 14. So it is 0 to 14, 0 to 14. Now these are the few methods that are very important, sometimes comes in handy. Now let's move forward. Let's see more things. Okay. Now this is about putting text and the markers inside of a plot. Now let's say I have okay. Let me explain you one more concept over here before jumping into that. Suppose we were talking about this graph. Okay, earlier there were two axes x y, and I was plotting x comma y. Now suppose I remove one axis from here. I am just crossing it, and I'm also removing its variable from over here. Now what do you think is gonna happen over here? Now let's run it and see. Okay. Yeah. So this is the graph. It's still plotted the graph. It does not need the other axis. What it does is it accepts the this whatever we are giving here x is equals to. If we are providing it only one axis, okay, we are inputting only one axis. What it does, it will take it as a y-axis. It will not. I'm writing over here x, but it will not take it as an x-axis. It will take it as a y-axis and implicitly creates an one x-axis from starting random starting numbers like consecutive numbers of 1, 2, 3, 4, 5, 6, 7, 8. Okay, it will suppose let me do this. Okay, so that you can understand this concept. I'm providing it y. So what it is gonna do is it's not gonna use y over here. It's gonna use y in this axis. Okay, and the implicit values that it will create, because I'm passing it only one axis, so it will create another axis implicitly, and it will give it random values like 0, 1, 2, 3, 4, 5, 6 are consecutive values from the start. Okay, according to what how our graph is going, it will implicitly does it. So that's what I was about to do it over here, where I've given it only one axis, x is equal 10, 20, 30, 40, 50, and I was plotting it. Now let me just run it and show you, then I will explain what all the things I was doing over here. Okay, just let me run this code. Now you see here, let me increase the size of the graph. Okay, so I was passing it the values 10, 20, 30, 40, 50, and those values are placed over here in the y-axis, not in the x-axis. Okay, and x-axis it implicitly took 0, 0.51, 1.52, 2.53, and so on. And what I did here is I said, okay, plot the graph on x-axis, and whatever the shape that you are gonna give it over here should be a plus sign. So all the points like 10, 1, 20, 2, 30, 3, 40, 4, 50, 5 are, sorry, I was saying wrong way. 1, 10 and 2, 20, 3, 30, 4, 40. These all will be placed, and all those points there will be a plus sign will be placed over there. And then what I said to it, place a plus sign, and I said plt.text at the point 0, 10. Now this is a text function. What text function takes? Its text function is used to write something inside of the graph. Okay, anywhere inside of the graph you can write it. And what it demands is, it demands the coordinates over here of the graph where you want to write it. So I provide the coordinates 0, 10. Then it says, give me the string, what you want to write over there. So I said first point, write the first point over there. Then I gave it another argument called color, that I want to write it in a green color. Then I can also say I want a size of like 20. Right. I want a size of like 20, and I can give other font style, and there are lots of parameters of it. You can check the documentation of the text method or the label method, and there you can see there are lots of keywords arguments that you can pass in to change the text size, text color, shape of the text, all of these. So right now we are we are working with this color and the size over here, and so yeah, so I've provided the two coordinates over here, 0, 10, first point, and color provided color as a green, size as 20. Okay, so what is happening over here is at the 0, 10th position, it printed out like type first point over here on the graph, as you can see over here, and then I gave it 1, 20 over here. So what it does, it 1, 20, it printed out the second string that we are passing it over there. Now there is one thing that you can do. One thing some of you have asked me on the WhatsApp group on how to do it, how to put coordinates of this. Instead of the second point, I want to put the coordinates. Like this is 1 comma 20 over here. I want 1 comma 20 written over here. Like the brackets, it says 1 comma 20. For each of the points that are inside of the graph. So that you can do it. You can do it over here. You try it at your when we are working with this. You can try it at your home. Try to put up coordinates over here and in this place. And write the place where I wrote first point. You write coordinates on that place. Okay, like 0, 10 or 1, 20. Okay. Now let's come to this marker thing. This small less I place. This is called a marker over here. Okay. Now there's a sequence called the you put up a this is a common thing. Okay, so what happens is I'm talking about this much section only right now. Okay, nothing else, this much section only. And here we can write three things. Like first we can write the color code of that place, of whatever the color of the marker. And then we can write the shape of the marker, like whatever the shape you want to give it, shape. And then we can if you want to use a line, you can write a line. You can give it a line shape or not. You want to create a line or not, that you can provide it over there. Okay, so these three things are inside of this string it takes, and let me show you how it does that. Now what happens is there's a plus sign over here. There's a plus sign over here. Now if I write here R over here in this side, okay, as you can see I wrote R plus, and if I run this code, now you see all of them become a red color over here. Same if I put a green over here, they will all become green. And if I put up a dash over here, now you see. Now there is a line drawn over all of those plus points that I have drawn. Now these plus are the points, and there is a line connecting to those points. Now what I can do is I can just remove one. Like I don't want there is a line going through all of those points. Okay, now these are some of the markers, and what they do is if you put up a dot over there, it will drop this kind of a symbol over there. Then if you put up a O over there, then it will create a big symbol like let me show you. If I say 0 O, and if I run this, you see there becomes this circle kind of a shape over there. Then you can I put this Jupyter notebook, on the drive. Even in the chat section, I'm seeing the team has already shared with you. You can go through with this. You can also look for the documentation, and there you can find all of those markers and the colors that you can use inside of this code over there. Okay, and you can modify it the way you want. Now let's move forward, and let's move on the types of charts that we are. Now there are lots of types of chart, like bar chart, pie chart, scatter plot, and histograms. So first we will start with the bar chart. Now what a bar chart is, most of you would know what a bar chart is. They're like two some kind of a bars created inside of a graph, and this is what a graph is. Let me show you how a graph looks like. I don't need NumPy library over here. I'm just gonna run this code and show you how this graph looks like. Okay, this is a bar graph. Okay, you see there are like the graphs. I have provided two arrays like earlier, X and the Y, and this time I use the method dot bar. Earlier we were using plt dot plot. Okay, now I'm using plt dot bar to create a bar chart. So I've used this method. It again takes two main inputs, like the axis X comma Y, and align is equal to center. This is the default. If we even don't write it, it will still be aligned to the center only. Means the 1, 2, 3, 4, 5 that you see in the x-axis will be at the center of the bar written. Now you can change the align to, let's say, align equals to edge, and they are the 1, 2, 3 are comes at the edges of these bars. Now there are several other methods to use inside of the bar chart, like the width method. Width in the default, its width of each bar is 0.8, but you can change the width by giving it an argument width equals to, let's say I want to give it 2, and if I run this code, I see the width has become 2, and because it didn't start overlapping over each other because I have increased the width, so it kind of looks like an histogram. But let's change the width to, let's say I want it 0.1. That's it. Okay, 0.1. Now you see its widths all reduced to 0.1, and that's how the graph looks like. Now, if you pass in, let's give it 0.5 or 6 so that you can look it clearly. And if I do it a negative, like minus 0.6, and let's see what happens. Earlier, when you were seeing when we are using a positive 0.6, what was happening is these numbers 1, 2, 3 x-axis numbers were coming at this side of the graph, right? But at this side of the bar, sorry. But right now, when I provided minus 0.6, all the bars are like left aligned. You can see the numbers are coming at the right side of the bar, 1, 2, 3, 4, 5. Now you can also provide the labels in this also by using plt.x label, plt.y labels. You can provide the titles. You can also provide, I haven't told you earlier, one method, plt.xTix. Now what this method does, it gives you the, like whatever the numbers you want in your list of the numbers that you want inside of the x-axis. Okay, it's like explicitly giving it what I want in the x-axis or what I want in the y-axis. Another is a plt.ysticks. Okay, here you pass in the list, not a string, sorry. Here you pass a list or like x or y, and accordingly, like if I pass over here the y, if I pass over here the y, and let's see, and here x. So what happens is the graph changed completely because right now the graph is working. I have just changed the axes completely. Earlier it was between x comma y, but now what I did, I passed y on the x-axis and x on the y-axis, and now the graph looks like this. This is how you can explicitly provide or you can say change the x or the y-axis. I'm just gonna remove it. It looks ugly right now. Okay. Now another method is the bottom. Another argument is the bottom argument. Now what bottom argument does is, let me show you. It changes the bottom of the, right now the bottom of all the bars is 0. But if I provide a bottom, like let's say I want bottom is equals to 1, and if I run this code, what happens is bottom has reached now to 1. Like now this is 2 and this is 1 over here. Now if I say bottom is equals to 7, let's see. You see bottom has reached to 7 and the bar is starting here. It is 8, then 9, 10, and so on. So that's what the bottom does. It changes the, mostly it uplifts all the bars according to it. If we have freeze the, let's say if I want to plt.yticks equals to, plt.yticks, and I want a y-axis over here. Now you see here, if y-axis started from the 2 only, as I have given it explicitly, and all the bars starts from the 7th point, or the whatever the value of 7 is, from there all the bars starts. So that's the use of the bottom. And if I say right now bottom equals to 0, you see bottom is starting from the bottom started from the 0th point, means goes more below, because the y-axis is starting from the 2nd point, from the point 2. Okay, so this is all on the bar chart. Well, there are other things like right now we are creating an vertical bar chart by using the method bar h. Just earlier we were using plt.bar. Now we will use plt.bar h, and if I run this, we can create an horizontal bar chart. The rest of all the methods are same. Changing the bottom, changing the bottom, changing the alignment, changing the what else, width. Rest everything will be same, other than the, all you have to do is put the bar h over here and it will create a horizontal bar chart. Now this is here we are creating an, earlier we were using this single bar chart over here, and there's only one bar chart, but now we will be using multiple bars there. Like not every time you get a one bar or one, only one kind of a bar in there. Sometimes you have to superimpose two or three kinds of bars. So that's what we are doing. Let me run this program and show you how that looks like. And then we will see what we are talking over here. So you see over here in this bar, I've got two bars here. One is blue color and the other is of orange color. They are all working together, defining something that we will see what they are defining. And there is also a legend that I've explained earlier with saying blue color is boys and orange color is what is this color is? It's girls. Now let's come to what this code we are doing, how we are doing it. Okay, so what I did is I created a one. This is a graph between class. There's a class and the marks of boys and girls in the class. So class 9, class 10, class 7, class 12, and there are the boys marks and the girls marks in the class. So what's happening over here is a class. These are all the highest marks. Okay, in the each class of the boys and the girls. So you see here, what I did is I created one array of S class 9, 10th, 11, 12, and I created as an x-axis, and I passed boys and girls, and I've converted into, I've put it as a y-axis over there. Then what I did is, if I remove this line, and let me show you. Simple, what I did is create 3-axis, and I passed plt.bar S class comma boys, and I provided the width of 0.4, and I gave it the label as boys. And then what I did, I plotted another bar graph which not bar one, let's say S class. Okay, right now. Okay, S class comma girls 0.4, and again the labels are girls. And now if I run it, and now you see here the bars are superimposed on each other. They are like they are stacked up. So most of the things you can't see here because in this girls bar is higher, so you can't see the bar of the boys. But here they are like almost divided, so it's not much of a good format to watch it. So what I did over here is I used these, I changed the the X values, these S class values of the another bar plot, and I shifted them so that they can become at the side of the another bar. So what I did was, not again, one more thing. It should be bar one over here, and they started looks like this. What I did is I know the widths are 0.4. So if I shift a bar 0.4, so what will happen? The bar will, if I shift the axis of the second bar, x-axis of the second bar by 0.4, as I've given the width is 0.4, and if I shift the x-axis of the bar 0.4, then all the these orange bars will shift 0.4 towards the right side of the x-axis. And that's what I did over here. I created one more list over here, bar 1, and what I did, all the S classes, I said all of these numbers 9, 10, 11, 12, I'm fetching each of the number one by one, and I'm adding 0.4 in it. So what I'm doing is I'm shifting the orange graphs one side towards 0.4 length of the side towards the right side, and that's what I did over here, and it shifted all. Sorry. Wait. Yeah. And they all shifted towards the right side of the graph. Now I did one more thing over here. Let me show you earlier how it looks like. Now you see here, when I shifted it, it looks like 9.0, 9.5, and it is coming at the orange. But I want this to be 9. They are both 9 only. Now this is of the 10th class, this is of the 11th class, and this is of the 12th class. Okay, but here it is giving 12.5, 11.5, and I don't want all of these. I want it to be properly aligned. Means 9 has to come at the center of this complete plot. Okay, blue and orange. So for that, what I did, I also shifted this x text over here to little bit. Means if the width is 0.4, so what I have to do, I have to shift the x text by 0.2. I have to increase the x text by 0.2. So that's what I did over here. I created another array, bar 2, and I plus 0.2. So what I did is I increased the values of the S class by 0.2, and I changed it here in the xticks where I said bar2 comma S class. So now if I change it over here, and now if I run it, you see it looks properly aligned, like 9 is at the center, and now it looks much more organized graph, right? And I've given it title, X label, Y labels. Guys, I've already provided you the notebook. My team has provided you the notebook, but whatever the changes I'm doing, we will again upload this notebook at the end of the session. So whatever the changes I'm doing right now, I'm writing lots of things. If you can write it, okay, it's a good thing. Just write it down with me, work with me. But if you are not writing it, you are just watching it, I will again upload the notebook at the end of the session, saving this notebook, and I will upload it again so that you can get all the edited things that I'm editing right now. Okay, I'm adding a lot of things, so you will get that too also. Okay, so don't worry about that. Okay, someone is saying, can you please explain this concept again? Okay, Bhavesh, I'm going to explain this concept once more. So let me again comment out this section. Okay. Okay, so this is how normally we will create a bar graph, right? We have got 3 arrays over here, X class, boys, and the girls. Okay, and what we did, we plot a graph between S class and boys, a bar graph with a width of 0.4, and the label we have given it boys. Then we have plot a graph between S class and the girls with the width of 0.4 and gave it a label of girls. Okay, and we give it title, X label, Y label, legend, that I've already explained earlier. And we created a graph, and what happens is graph superimposed on each other. Okay, and which due to which we cannot see properly what is how how a graph is working. We can't see what is the value of the boys in the 11th class or in the 12th class. Anywhere here we can't see from where it is starting. So it's a very ugly graph. We can't understand anything out of this graph. So what we want is that these both graphs, these both bars come separately inside of this plot. Okay, that there should be a one complete blue plot and another blue or complete orange bar. So that's what we want. So what I did over here is I shifted the S class values of the girls by the 0.4. That is the width of the one bar. So what I did, I just shifted the width of the S class by 0.4. So I created another array. Now if I print that array, let's say like I write it over here, print bar1, and you see there is another array I have created, bar1, that is 9.4, 10.4, 11.4, and 12.4. And now I am placing this bar, second bar of the orange color of the girls, and I'm passing bar1 over here. Now this array, this list, sorry, I'm passing this list over here. Instead of 9, 10, 11, 12, I'm passing 9.4. So what will happen is the bar of the boys will form at the ninth coordinate of x-axis, and bar of the orange of the girls will form at 9.4. Hence they will look separate. So if I now run it, now they look separate here. This is the bar of the 9 boys at the 9, and 9.4 there is of the orange. But again there is a one little bit of a thing that it's saying 9.5 and 10.5, 11.5 and 12.5. Now this is we don't want this, because this complete graph is of the 9th class. There is nothing 9.5 class. Okay, so what we did is we shifted the x-tick value so that this 9 can come at the center of this bar plot, this complete bar plot comprising of blue and orange. Okay, 9 can come at the center. Now to bring it to the center, we have to shift the x-tick 0.2 we have to shift the x-sticks to the right by 0.2, right? Because the whole width is 0.4 and it's already at the center, so we have to move it 0.2. So that's what I did over here. I created another list, bar2, by adding 0.2 in each of the number of the S class, and I changed the ticks values by passing here bar2. And now if I run it, now all the values 9, 10, 11, 12 are shifted 0.2 side, and it removes the 9.5 from the x-axis. Now it looks a much more organized graph. Okay, so this was all the bar chart. Now everyone is clear about the bar chart. Can you please tell me in the chat? Can you please write it on the chat if you are clear right now with the bar, with this concept of the bar chart? Okay, thank you. Now let's move on to a histogram. Now histogram is a very easy concept. Okay, what I did over here is I call just a normal Python library is called random library, because I want to generate some random numbers. Okay, every time we were predefining the arrays, but right now what I did, I said, okay, let's create a random numbers, and I imported random from random module, and I use this method. So I use this method I call that give the initial value as 15 and last value as 80 for I in range 100, and I want 100 values between 15 to 80. Okay, so what happens is if I print x over here, print x. Okay, now you see I got around 100 random values between 50 to 80, or 15 to 80 over here. And then what I did, I took a I took a y-axis over here, and I passed it over here. plt.hist x comma bins is equals to y. I'm gonna explain what our bins are, and ec is equals to red, that I'm also gonna explain. So this is how histogram looks like. Okay, now bins are these bars that you see over here. Now these are not a bars. When you talk about histogram, let me do this. Let me show you. Histograms looks like this. These are not the bars. These are, they are like the intervals. Like from 20 to 30, there are 15 students between the age group 20 to 30. Then there are in between 13 to 40, there are around 16.5 students. Then in 40 to 50, there are around what do you say? It's like 11 students. So it creates an interval of the age group, and in between these age group, these many students lie. So okay, so these are the bins, the defining of the age groups that we do. So here I pass the bins is equals to y. You can give it pass it any list or any number over here. Then I wrote one more argument where ec is equals to, I said red. Okay, now what ec does is, EC means edge color. It's a short form of the edge color, and what it is, it creates the edges around our bar histogram. Now you see, every time our histogram is changing, it's just because we have passed the random number here. So every time x-axis is getting a random numbers, and so every time our histogram is changing. So what this red EC does is it's create a boundary so that we can easily understand where one bin is ending and one is starting. Okay. So that's what EC does. Then in general, we have given the title as a histogram of age, X level, Y level. Okay, if you have using the stacked, you can also use create a histogram, horizontal histograms. You can also stack the histograms like we did over here with the bar charts. That you should try it with yourself. Okay, and in that also you can create legends. You can define 2 to 3 colors for the histograms. Like here, I did not tell you one thing. You can predefine the colors over here, like saying color is equals to, I want it to be red. Okay, now if I run it, now I predefine the color, and I gave it that y should be in the red color. Same way I can do it in the histogram. I can say color is equals to green, and now if I run it, you see a complete histogram become a green color. Now there are lots of other methods where you can change each bin of you can pass out the color for each bin using the creating a list and passing in the CMap and all. Now there are lots of methods instead of it. You can go through the documentation. You can find there are lots of things that you can do, but these are all the basic things. I'm going to explain to you right now the basic thing that you will need while creating a machine learning models. The stuff that is like required over there, because if we start talking about the graphs, then every kind of a graph can take about 2 to 3 hours of working because they have so much inside of it. And after this workshop, we are gonna, soon we will bring out a complete matplotlib and Seaborn complete video tutorials, complete tutorials on it, and there we will be explaining you each and every graph in very much detail using all the arguments, talking about keywords, arguments, and everything. Okay, now pie chart. Now pie charts, pie charts, they're like look like those circle things divided in the wedges and all. Now this is a pie chart. Let me run and show you. Okay, so these are how pie charts looks like, and how I made it is I pass in some values inside of the x-axis. Okay, these values I gave it in the x-axis, and in the y-axis I gave it some names like C, Python, C++, Java. This is voting. This is a kind of a survey where we surveyed like which language is more popular, and Python has got the votes of 7,665. Java has got the votes of 7,560. C++ got the votes this much, and C this much. And don't worry about the explode right now, okay? And what happened is then we create this plot, and let me remove the explode right now so that you can understand how. Okay, this is how it looks like. Okay, we have provided an edge color also as a black. This comes under the dictionary of wedge props. So kindly look at it. There are lots of key value pairs inside of the wedge props you can work with. You can look at it. You can look at the documentations of the pie charts in the matplotlib. But here we are more concerned about the edge color because it defines the edges clearly inside of our pie chart. So what happens is here, Python has the highest number of, like likes over here. So it has got the bigger shape over here, bigger angle. Same way, somewhat similar is Java. So it has also got some similar angle. And C has the least number of likes. So you can see the angle of the C++ looks a little bit of less. So that's how we create a pie charts. Now what I said, I gave it here an explode over here. Now what explode does is it creates a let me show you. It emphasize, or you can say explode out one of the wedge or whatever the wedge you want to explode outside of the pie chart. So when I created this explode over here, what it does, you can see here Python. What I did, wait a minute. Yep. Okay, sorry, wait a minute, just hold on. Okay, I got a water on my mouse pad and it is behaving erratically. Yep. So what I did over is I created a list named explode, or I can name this list as whatever I want to give it a type. So what here I pass values like 0, 0.2, 0, and 0. Now what happens is this list will walk according to these above two lists of X and the Y. Now you see at the 0th position there is C language, and I pass the 0 value for the C position. Then I pass 0.2 for the Python position, 0 for the C++ position, and another 0 for the Java position. So what I said, I want to by explode means I want 0.2 size of the width. I want it exploded that section out of the pie graph. So what it did, it exploded Python because 0.2 was put at the Python. So it exploded Python out of that pie chart and put an emphasize on it, or you can say separate it from the pie chart. It is basically used to emphasize it. For this pie chart, I want to emphasize something. Now if I say I want to emphasize this also, Java also at 0.5, and now if I run it, you see Java is also being separated from the graph with the width of 0.5 over here. Now that's the sorry, that's the width we are providing over here, 0.5 or the 0.2. Now here we have provided a shadow is equal to true. The shadow somewhat created give it a 3D look kind of a thing. You can see over here it is creating a shadow around the graph pie chart. and the starting is start angle is 90 degree. I mean, it's used to rotate, rotate your pie chart. You want to give it angle, you want to create a start angle as 90 or whatever. It is used to rotate the graph. So that's all in the pie chart. Okay, now we will move on to the scatter plot, and let's run it also like everyone else. The scatter plot is like, scattered some dots that are scattered all over the graph. So I passed two arrays again, just like all the time. X array, I passed some values in the side of the X and the Y, and I created used the method plt.scatter to create this plot, and I passed both the the X comma Y, and I gave it edge color as red. So what it does is, if you see it, it has created a edges of red color, and I passed the C is equal to green, means the color of the whatever the scatter we are creating will be green, and I gave it the S is equals to 100, means the size of that this scatter plot will become 100. I can pass it like, I can say 200 over here, and you see the size will increase of it. So that's all in the scatter plot. If you have any doubt, you can ask me right now. Anyone with the quick recap of the pie chart? Okay, does explode pair only the highest number of values? No, explode whatever we will provide it over here. Okay, let's remove it. Okay, C++ was the list. Okay, whatever the width, take explode list as a width. We are saying everyone else should be at the 0th width, but the width between that C++ and the pie chart should be 0.4. Now if I run it, I see C++ came out of the pie chart with a width of 0.4 from all the sides. That is the concept of the explode. Okay, now the person who wants the quick recap of the pie chart, Rishabh. Okay, pie chart is nothing, it's simple. You give it a plt.pie method, it's a pie chart. You provide it a label, X label, and these C, Python, Java, C++, you provide it as the labels. These are all the labels of this pie chart. You provide it as labels is equal to Y, that we have provided a list over here. Then there's a dictionary wedge props, which contains edge color, edge size, and all. There are lots of key value pairs inside of it. Right now I'm using only edge color, and I provide edge color as black. So what it does is it creates a black background around each of the wedges that you can see over here. Then I gave it a shadow is equal to true. What shadow is equal to true does, it creates a shadow around the, this complete pie chart, makes it looks a little bit of a 3D kind of a structure. Okay, and then I gave it explode is equal to explode, that I've already explained. Okay, it is used to explode something out of the pie chart, or put emphasis on the pie chart, on the some wedge on the pie chart. And start angle is equal to 90. That means it is used to rotate the pie chart. That's all inside of the pie chart. If I want to see numbers as well, yeah, for the numbers there is a method called right now I am just missing it. I have to check it. There's a pie counter method, something like PICNT method, and that you provided the floating point number like a percent sign 1.2%, and that way it will give you the percentage of the how much percentage that section is covering inside of the pie chart. And you can also use one simple thing. You don't have to use even this also. You can use plt.text method that I have explained earlier over here. That is this plt.text method, and you can use it over here to plot it on the pie charts. Okay. So now let's move on to scatter plots over. Let's move on to 3D graphs. Now earlier we were all creating those 2D graphs. Now 3D graphs requires one special library. This inside of the matplotlib is mpl_toolkits, and from which we are importing mplot3d. Now this also works parallel with the matplotlib. It's not like you are not using matplotlib and you are using this library and you will be able to create 3D plots. No, you will not be able to create a 3D plot. You will be needing a matplotlib all over this while creating a graphs inside of it. So we to create a 3D graph, we require these two this library only from MPL. Now NumPy library, you already know. I've used NumPy library to create these numpys or zeros, some kind of arrays, zeros and ones. Now what happens, what is happening over here is in this set of code is, let me run it and show you first. Now this is how a 3D graph looks like, and I haven't imported NumPy library. Wait a minute. Yeah. So what happens here is I've created, when I've imported a module PLT, I've created a, I've called this method over here. I created an object, fake object over here. We're using plt.figure method. And to create a 3D models, there is this method you have to use, fake.add subplot, where you have to state that projection is equals to 3D. If you are using an older version, then I think in an older version you don't have to write 111 over here. And the library that you have to import over here is access 3D, not mplot 3D. Okay, mplot 3D comes over here, inside of the mplot 3D. Inside of the mplot 3D, you will be importing access 3D over here, but that is deprecated right now, and in the latest version it is directly, we have directly import the mplot 3D over here, and it works perfectly fine. So if we are creating 3D array, then we need 3 axes, right? So we have provided x, y, z, and to plot a graph, earlier we were plotting 2D graphs, so we are using plot normal plot method, but right now we are using plot 3D method for plotting a 3D graphs. And this ax1, here we have called this method for projection 3D, like because we are using we are going to create a 3D graphs, so we have already tell matplotlib that we are going to create we are creating a 3D graphs. We need a 3D look, this 3D background over here. So that's why I've created an object of ax1, and we will be using that ax1 object over here. And earlier we were using plt object, now we will be using ax1. You can in fact, you can right now use PLT even over here also for creating x-axis or y-axis, but PLT does not support the third axis, z-axis. Okay, and let me show you over here. What we used to do earlier is, wait a minute. We used to do PLT dot x label, right? And if I run this line, it is still working, PLT dot x label, and I'm getting an x-axis over here. But if I say plt.z label, it's a third axis, and it gives me an error that matplotlib.pyplot has no attributes z label. That's why we have to use this, because it comes under this projection 3D, this add subplot method. So we have to use this object only over there, ax1.set z label. And if I run it, it will work perfectly fine. Z-axis over here, y-axis, x-axis. Now it's a 3D graph, and the Colab or the Jupyter does not support much easily those 3D graphs. You might see some kind of problem. But if you are working on the Visual Studio or the PyCharm or the Spider, there you can see these graphs very properly, these axes very properly. Now I pass those three arrows over here, and those people, someone is asking what is meant by 111. 111 means I'm passing a I'm giving a 3 axis over here. So it is it defines that 111 defines the value of like 3D, that is 3D over there. Now I'm plotting this 3, so I provided this. It is just like, everything in the 3D graph is just like the 2D graphs. All the arguments inside of the 3D graph is like a 2D graph. It's just one axis is only increased over here. And we give the 3 axis, right? Rest, colors, brown, label is equal to line, and mark. You can put up the markers, you can put up everything, and you can put up the legends over here. Everything will work exactly the way it used to work in the 2D graphs, and you can plot a graph over here. Now don't see this graph as this graph is not on any of the following that background sheets that you see, this grids over here. Okay, this is in the space over here. Like if you look at your room over there, so this line is floating between your between the walls of your room, not on any of the wall. Okay, these are on the between of all those all those four walls, and bottom and the roof and the top. Sorry, roof and the bottom. Okay, it is between that room. This line is okay. So don't get confused with that this line is on the like this line is on this frame over here. No, it is in the middle of that complete cube, a cuboid. Now this is how we create a line graph. Same way we can create a bar plot over here like this. Now in the bar plot there is one more thing we add over here is now bar plot require lots of things like we have to provide the position from which the plot is starting. Okay, the axes, all the three axes of the position from which the bar is starting, and we also have to provide how much thickness, how much height, and how much width that bar is having, because we are creating a cubes, and those cubes are inside of a 3D graph. So we requires first we give it the positions in the x comma y comma z. Now z is the height over here, x comma y are the positions in the axis where we are plotting it. Then we have to give it dx comma dy and dz, as these are the height, width, and the what's the third, length of the bar graph. Like suppose if I just reduce it to zeros, zeros, okay, now this complete axis becomes 0, means it is x, the dx is 0 comma 0 comma 0 comma 0, and now if I run it, you see we have lost the width in the bars. They all have the height and the length, but they don't have the width. And if I even convert it into zeros, now they are vanished because their length is also 0, their width is also 0, so they are not even existing in the plane. So let's put it back to ones. Okay, so that what we are passing over here, x, y, z, we are passing the position where the bar plot, where we are plotting that bar chart, and then we are passing the these three dx comma dy comma dz as the height, width, and the length of the bar plot, and then we are passing color is equal to red. Then you can pass in the edge colors, you can pass different kinds of all the keywords arguments over here. Then you can pass the labels, titles in the graph, legends in the graph. You can also create a multiple bar plots in 3D. Okay, just like you were doing in the 2D, you can create one more method over here, ax1.bar 3D, and you can pass in different arrays, and they will form over here with a different color. So this is in the 3D bar graphs. Now we will talk about the scatter plot in the 3D. So same thing the bar graph is, or the line graph is, same is the scatter graph or any 3D graphs. Their thing is all the same. Just the one thing is, in the bar graph we were needing the height, width, and the length of the bars because they're all cuboids. There we don't need it because they're all the scatter circles will be over there. Let me show you how. Now these are all the scattered circles over here. Now you see some circles are bright and some are dull, some are dark. Now that's because this thing defines how close the circle is towards you and how deep. Suppose you take a one glass cube, complete glass cube, and if there is something inside of it, if it is like beyond in the opposite side of the cube, then you will see it very lightly. But if it is closer to your side, then you will see it dark. You can see somewhat clearly. Same thing is over here. Suppose it is our glass cube, and the axis, then the scatter plots that are light in color are like they are in deep inside of that cube, and those are dark, they are closer. They are all in the air. Don't think that this is at this plane over here at the axis of 8, 0. No, these are not at those axes. These are all in the on the 3D graph over here in the middle of the room. Okay, yeah, these are all in the middle of the room. Okay, they are like floating in the middle of these points in the triple axes. And same thing with all the here we have your C map is equal to green because it helps us separating these between light to dark. It helps us separate the colors. And I said C is equals to W. So what it is doing is I'm passing the colors as an axis over here, complete axis. Okay, this not an axis, I would say a list of colors. Like if it is 0, that means it will be light, or closer to 0 means it will be light, or if a number is greater, then it will be a dark. Like if a number is 9, 9 is at 0, 1, 1, 2, 3, 4, 5, 6. So whatever will be at the sixth position will be darker in color. Whatever is at the 0th position, at this last position will be lighter in color. Okay, what's happening? So that's in the, and the S is equal to 100. I've told you earlier, the S is the size of these. Okay, why am I getting hit by the virus right now? Okay, S is equals to 100. I already told you. Okay, S defines the size of all these 3D of all the scatter plots present over there, and that is it in the, I guess, in the scatter plot. You can use all the methods that you were using in the 2D scatters, all the keyword arguments that you can all apply over here. It just needs an one axis extra, rest everything is same. Now we will talk about the live graph, and in the live graph we will be talking about specific graph bar chart race. Now in the lots of YouTube videos you have seen, they have this kind of a horizontal bar. They keep on running, okay, like keep on updating and keep on running, moving forward. Like suppose it's about the popularity of the actors or the actresses. They have a bar chart running from like 19th century up to the present time, and their popularity, the most popular person keeps on coming at the top, least popular person at the bottom, and they keep on shuffling between them. So that's what today we are going to create. We are going to create this live graph of a bar chart race. That kind of a graph is called a bar chart race, where there is a kind of a race between the bars. Okay, who is at the top will be who is at the ahead in the race will be at the top. Who is at the bottom is at the last in the race will be at the bottom. So for that we will be needing some specific libraries like bar chart race, and this is a one player FFmpeg Python. This player is required to play that complete animation of that bar charts. Okay, so I'm gonna just install, and I'm gonna run all of this program because it takes quite some time to load, and by the time I'm gonna explain you everything over here. So here I have installed by using this method. I've installed bar chart race module over here. Okay, that's successfully installed. And then I have installed FFmpeg-Python. This is a media player. It has also successfully installed. Now that's the media player that I was talking about, and I was telling you that why I chose Colab and not the Jupyter. Because in Colab I can directly work with this module, whereas in the Jupyter I have to download it, and then I have to set it up as an environment variable, and then I can use it on the Jupyter. That was a big task. And I'm a little bit lazy. So what I did is I imported bar chart race module over here as BCR, and I imported a pandas library over here. After that, I imported the CSV library, CSV file that I've created. And to upload a CSV file, let me show you how to upload a CSV file. Okay, there's this folder option over here. Just click on it, and you can see this section over here. In yours, you will be able to see the sample data over here. And I have uploaded these two files so I can see these. So what you have to do is, there's this upload section. Click on this upload file section. Right on it. It's loading. Yeah. Now from here, you can browse the file, whatever you want the file to put it into a CSV file. We have provided you this CSV file already in the chat section. The links is provided in the description also. So you can get the CSV file from there, and you can upload it to this process directly. Okay. By clicking on it, you can upload the file. And then when you upload the file, click on the triple dot over here and copy the path from here. Okay, so you will get the path of that file, and then go over here, use this pandas method to read CSV file, and pass in the the path of the CSV file over here. Yep, coming again. Okay, so you pass the CSV file, and don't forget to use the R over here. It says, read the CSV file. Don't forget to use the R to use this string formatting over here. it will not, it will give you error if you are not using R in the notebooks. If you are in the Spider or PyCharm or anywhere, you don't have to use the R. But if you're in the notebook, you have to use it. Okay, if you run it, the I saved this complete CSV file, this uh, data frame inside of my df variable over here. And then what I did, I df.tail, I used the df.tail method to see the, my, oh god. Now this is the complete data of that I fetched from the API of the COVID-19.org. I fetched the COVID-19 confirmed cases of COVID-19 of all the states, and it's a date-wise cases. Okay, let's see where it goes up to 2nd of October 2020. I fetched it last night only, and it starts from, if I use the df.head method. Okay, wait, my program is it is still executing. This could you show us the import code for loading CSV file from the drive? Yeah, okay. Earlier I have shown you this small code I told you earlier. Now this is a code from through which you can mount your drive inside of the Google Drive, inside of the Google Colab, sorry. Okay, or you can also mount your Google Colab by clicking on this mount drive icon over here, and then they will ask you for the verification code and all, and they will mount your drive over here. Or you can use this code over here to mount your drive inside of the code. Then you will get a fun folder over here as like a drive folder. And I'm not gonna mount right now because I'm using a Tor browser, and Tor browser keeps on asking for the verification again and again every time I mount, and I'm not gonna verify right now inside the Tor browser. So I'm not adding it, but you can add it. You will get a drive folder over here. Inside the drive folder, you will get all the, when you will click on the drive folder, you will get all the folders that are present inside the Google Drive. And the same way, you can click on the triple dots and you can copy the path from there.